Welcome back to our lesson practice review, where we today talk about chapter 3, lesson 3. The lesson talks really about, it's very much building on our lesson 2, where we talked about end behavior, but we now have these polynomial functions that have more than one term. So what we need to understand about that is that these polynomial functions, they really emphasize the idea of what's called a degree and a leading coefficient. And so we're really looking for where's the highest exponent, or the greatest exponent is the words they use. And that is the term that is going to tell us most about what our end behavior looks like and what our function's shape is going to be. So when we look at these, again, a table here that gives you a couple different examples. This will be good to review as you're trying this on your own. But again, when we're looking at this is a positive leading coefficient and an odd degree, because this is our highest exponent. It's positive and the degree, or the exponent, is odd. Whereas a negative leading coefficient and odd degree would be this one, because the highest exponent is 5 and that leading coefficient is negative. Even degree would be this one here, because it's the greatest exponent and the coefficient is positive. And then this one here, the greatest exponent is 6 and the leading coefficient is negative. And so you can kind of see what that does to our end behaviors. The shapes look a little bit different just because of what degree or what the actual exponent is, but the even and odd and then the leading coefficient kind of tells us what we need to know about our end behavior. So problems 1 and 2, circle the expression that has the same end behavior as each polynomial. So for number 1, we see here that the highest exponent is 4 and the coefficient is negative. So I would say that if we just had a expression that had a negative coefficient and a exponent of 4, looks good to me. For number 2, our highest exponent is 4 and the leading coefficient is positive 5. So I would say that this expression would have the exact same end behavior as well. For number 3, sketch a graph of a polynomial that has the same end behavior as q of x. So in this one here, the thing that tells us the end behavior is that we have a positive exponent, an even exponent, which would mean that they point in the same direction, and a negative coefficient, which means that that same direction points down. So anything that looks like this, is good with me. If you want to have it looking like this, great. If you want it to look, just like something we've seen before, like a parabola, great. If you want to do something like absolute value function, great. As long as the left and the right side are both pointing down, that would be a polynomial that has the same end behavior as this. I guess it said polynomial, so absolute value, I can't do that one. But the quadratic is a polynomial, and the dark blue one that I drew there is a polynomial as well. All right, problems 4 through 7, determine the end behavior for each function. So when I look at this, I'm looking for the degree here, which the highest exponent is 3, meaning that they point in different directions. And then the leading coefficient is negative, so the right side is pointing down, which means that the left side points towards positive infinity, and the right side here points towards negative infinity. For number 5, we're looking for the greatest exponent, which is 6. It's even, so they point in the same direction, and the coefficient is positive, meaning the right side points up. And so both the left side, as x approaches negative infinity, approach positive infinity, and as x approaches positive infinity, c of x approaches positive infinity, since the left side and the right side are both pointing up. For number 6, d of x, we have the highest exponent, which is 5, and the coefficient is positive, so the right side is pointing up. And since the exponent is odd, the left side is going to point down. So as x goes towards negative infinity, d of x goes towards negative infinity. As x goes towards positive infinity, d of x goes towards positive infinity. Last one here, number 7. We look for the highest exponent, which is power of 8. The coefficient is negative, so the right side is pointing down. The exponent is even, so they both point the same direction. Since they're both pointing down, both parts of the end behavior here are pointing towards negative infinity. Number 8, which function is a polynomial of the same degree as g of x? And so when I look at this degree, I see that the highest exponent is the power of 4. And so in this one here, the highest exponent with a power of 4 is going to be d. Since this one, none of these have the highest exponent of 4, a, b, or c. Number 9, select all of the fourth degree polynomials. So fourth degree, meaning that the highest exponent in the equation is 4. So if I just go through and I quickly circle all the highest exponents in each equation, which of these has the highest exponent of 4? That would be a, b, and d. So this one, because it's a fifth degree, and this one is a sixth degree polynomial. Number 10, use each of the integers 0 to 9 only once to create two polynomials that have this as an end behavior. The left side points towards positive infinity, the right side points towards negative infinity. So the things that I need to know about this is that it is an odd function, or odd degree, and that it has a negative leading coefficient because the right side is pointing down. So and this one here, 0 to 9, so I can kind of go through this pretty straightforward. Since the leading coefficient needs to be negative, I'll do, this is going to be 9, and this one is going to be 8 because there are negatives here. And so from there, I can really kind of plug in any other numbers, I think, and it would be fine. 1, 2, 3, 4, 5, and 6. 7. Oh, oops. I forgot 0. Let's do this. I'm switching 0 to here. This is 1, and this is 7. So I couldn't put 0 in the front, or the coefficient wouldn't be negative, which is why I couldn't put 0 there. But otherwise, really, the focus is these terms right here, which has a negative coefficient. Oh, I made a mistake. This is why you can't rush through these things. It needs to be odd. So in this one here, I'm actually going to switch these two. I'll make the coefficient 8, and I'll make the exponent there 7. So that should be good. Sorry about that. I was kind of rushing through this here, but again, I was looking for highest exponent being making the leading coefficient negative, and then I need to make sure that that exponent is an odd number. So now both of those should have the correct end behavior to match. But again, there's lots of different possible answers. You're really just looking to make sure that the exponent is odd, the largest exponent is odd, and that leading coefficient is negative. For the spiral review, problems 11 to 12, write each quadratic equation in standard form. So to do this, I'm going to use my box method here to just multiply these together and then combine like terms. Negative 12x and negative 8. The only like terms are these corner boxes, which is mostly true when I am using the box method, which is kind of why I like it. So y equals 3x squared minus 10x minus 8. For number 12, box method, to multiply these together, I get 8x squared, 12x, negative 2x, and negative 3. My only like terms are in those corner boxes, so 8x squared plus 10x minus 3. And that gives me my answer for number 12 by multiplying these together to put the quadratics in standard form. That wraps up Chapter 3, Lesson 3, which again is focusing on us understanding what the word degree means, when it is odd and even, and the coefficient is positive or negative, and what that does to my graphs, or what it does to my end behavior.